All right, so 1.4, we're going to talk about exponents, order of operations, and variable expressions of equations. A couple things I want to go to on our PowerPoint that I do want you to see. And it's basically this screen right here is dealing with let me get to the right settings. Is when we're talking about exponents, okay? And what are exponents? So if you see here this 4 squared, this does not mean, the common mistake is this means 4 times 2. And what it does mean is 4 times 4. Okay, so 4 squared is actually 4 times 4, which would be 16. Same thing, 2 squared, 2 times 2, which would be 4. 3 to the 4th. Again, you're going to take the 3, you're multiplying it by itself 4 times, and that'll get you to the 81. 9 to the 1st power is just going to be 9. We don't necessarily see the fractions all that much, but if you did have 2 to the 5th to the 3rd, that would mean 2 to the 5th times 2 to the 5th, and again, you're just multiplying straight across each time. And we definitely won't see decimals all that much. But that would be how you would do that. The other screen I think is really important. And this one basically is the same thing, but it's this screen right here. And it's the order of operations screen. The reason I bring this up is a lot of people, when they remember this phrase, "Please excuse my dear Aunt Sally." Okay, and that is good in some things, but the common mistake with "please excuse my dear Aunt Sally" is when you get to the multiplication and division and adding and subtracting, because you don't always multiply first, okay, in order of operations. When you are multiplying and dividing, you always do whatever comes first, going left to right in the problem. Okay, and same thing with addition and subtraction. We always do from left to right. So parentheses still, yes, we will always do parentheses first. Then we will do exponents, okay? Then we're looking for multiplication and division. Again, those happen at the same time. And which ones do you do first? You do whatever appears first, left to right, like you're reading a book. And then the same thing when you're adding and subtracting. So those are the two kind of most important things on that slideshow that I want you to be familiar with. And again, I strongly recommend before you go right into these videos or go right into your assignment, you kind of go through the PowerPoint first that you can locate on your document sharing page. So you go to your document sharing page and you pull up the PowerPoint. All the PowerPoints are available for chapter 1 and 2. So I would watch the PowerPoint or go through the PowerPoint first. Then you may want to attempt the assignment, and if you're confused, then obviously go to the YouTube video, go to my YouTube page, and view the assignments. Or kind of like I said, I try to do an example of every type of problem you will see. So the first problem is a fraction, 8/9, and you're squaring it. So really what you're doing whenever you see that is you're going to apply that 8 squared to each number inside the parentheses. So you have 8 squared over 9 squared. So 8 times 8 would give me 64. And actually, let me write that out. So we're doing 8 times 8 there, 9 times 9 there, which again would give me 64 over 81. And again, what I would recommend you do, see, can I reduce this? And it's actually already in its lowest forms. So that's how you are solving exponents. The second example actually goes right into our order of operations. And this is a common kind of thing. If you weren't really taught this, or you're not really good at this kind of stuff, it's easy to make mistakes on it. Because you look at this problem and you think, okay, am I going to add the 9 and 6 first and then multiply it by 5? No, just go back to our order of operations. Again, if you remember that slide of the order of operations. And again, I'm talking about this slide right here. Okay, and just kind of visually ask yourself, do I have parentheses? Do I have exponents? Do I have to multiply or divide? Because the last thing you always want to do in these problems is add and subtract. So I don't have parentheses, I don't have exponents. Do I have multiplication? That I do. And again, I really kind of do these slowly. So I'm gonna, this is the first thing I would do in this problem is multiply 6 times 5. 6 times 5 would give me 30. And then I'm just moving down that 9 plus to put in front of the 30. Okay, so that's all. The only operation I have left is 9 plus 30. So that is just going to give me 39. So not so bad there. It's kind of an easier type of order of operations problem. But let's get into a little more complicated ones. Again, if you always ask yourself the same things with these order of operations, I think it's less likely you make a mistake. So do I have parentheses? I do not have parentheses. Do I have exponents? I do not have exponents. Do I have multiplication or division? I do. And what you'll notice is I have a multiplication here and a multiplication here as well. And the rule says, which multiplication do I do first? I do the one that comes first going left to right. So I would do this one first. So I would do 7 times 5 would be the first thing I do. And that's going to give me 35. Now I'm just going to move everything else down. Okay. So I did one of the multiplications. I still have another multiplication here as well. So at this point I would do that. I'm not going into my subtraction until I'm done with all my multiplications. But this time I'm moving down the 35, and 4 times 8 would give me 32. And this is again my last step. What's 35? Take away 32. My answer would be 3. All right, so that's how you solve these. Multiplication, you do this one first, then you do the 4 times 8, then and the last step we had to do on that problem was subtract. So let's look at a problem that's going to kind of have everything in it. All right, so this kind of does have a little bit of everything. Again, where do we start with? We start with parentheses. I do have parentheses in this problem. So that would be the first thing that I do. And in that, inside those parentheses, it's telling me to take 8 and subtract 3. So what does 8 take away 3? That gives me 5. Now at that point, you can drop the parentheses, you can keep them on there, but really they're not needed anymore. So I'm just moving, at that point, I just move the other stuff down because I haven't done anything with them. I try to do everything step by step. I'm not skipping steps here. So I don't have any more parentheses. What's the next thing I'm looking at? I'm looking for exponents. And I do have an exponent right here. What is 2 squared? That is 2 times 2, which gives me 4. So at that point, I move everything down. And you may be tempted just to add all these up, and at that point you probably could, but again, I'm going to do this following our order of operations. And even though I do have all addition left, the rule is you do it left to right, okay? So in other words, I don't go 5 plus 4 first, I would do 7 plus 5 first. 7 plus 5 would give me 12. I move down the plus 4, and then I'm doing 12 plus 4, and that would give me 16. So that again is a step-by-step order of operations. And if you do it, like I said, step by step, you're less likely to make mistakes. And if you kind of just ask yourself, going through those order of operations, really the way we have it set up, there's really only 4 steps, right? Parentheses, exponents, multiplication and division, again, happen at the same time, and addition and subtraction both happen at the same time. And you do it again left to right. That's how you know which one you do first. All right, so we're dealing with fractions. I know we're not a big fan of fractions, but we are going to do our best we can with them. And what we have is we have a multiplication problem here, followed by a subtraction problem. So again, we're dealing with order of operations. So the first thing I'm going to look for again is parentheses. I don't have parentheses. Move on to the next one. Exponents. Do I have exponents? I don't have exponents. Now we're done. The last thing is addition, subtraction. I mean, multiplication, division. Addition, subtraction is last. Okay, so I do have multiplication here. So I got to do this first before I subtract the 1/3. So I'm doing this first, and hopefully you notice these 8s here. They're just really going to cancel each other out. But if you want, you could put 1s in their place. And then I'm just doing 1 times 1 gives me 1. And 1 times 3 gives me 3. Then I'm going to move down this minus 1/3. Well, remember, anything minus itself is going to give me 0. But if you don't recognize that, you keep that denominator. And 1 take away 1 would give me 0/3. And 0/3 is just 0. Anytime you have 0 in your numerator, it's 0. If you have 0 in your denominator, it's undefined. So the answer to that problem would be just 0. All right, another order of operation problem. It's also again in fraction form. Now when we're dealing with order of operations and we're dealing with them as fractions, you really could do each of these kind of as a separate problem. Okay, in other words, you can just solve that by itself and then solve that by itself, and then just whatever you got, you can bring it back in at the end. But we'll do these kind of at the same time. So order of operations, we're looking for parentheses. I don't have any parentheses in this problem. I'm looking for exponents. I don't have exponents. Next thing I'm looking for is multiplication or division. I do have multiplication or division, right? I have it right here. 3 times 2. So technically I would do that first. 3 times 2 would give me 6. So I have now 16 minus 6 over 6 minus 4. So these kind of subtraction problems occur at the same time. It doesn't really matter which one you do first. Like I said, when it's a fraction, you can kind of do them separately. But 16 take away 6 would give me 10. And 6 take away 4 would give me 2. And this is not in reduced form. But basically 10, what is 10 divided by 2? 10 divided by 2 is just 5. So my answer on that problem would be 5. If you enter this 5/1, I'm not sure to mark it wrong, but 5/1 is also the same as just 5. All right, and the last thing we're doing is variable expressions and equations. So now we're dealing with variables. And what a variable is variables represents unknown numbers. Well, in this case, though, there actually are going to be they're going to be known numbers. And again, this is a z over 7x. And then what it's telling you is that x equals 3 and z equals 7. So in this case, they're giving you the values of these variables. So these are variables, these are letters, okay? But they're giving you the value of these letters. So what you have to do is substitute these values in wherever you see those letters. And the way I always do this is I'm going to take this original problem, and everywhere there's a variable, I'm just going to write a parentheses. So I had the only number was the 7, because it was 7x. And again, what that means is 7 times x. Okay, and then you had your z. Now I'm going to plug in my values. What was z equal to? Well, it tells me z is equal to 7. So where the z was, I'm going to replace that with the 7. I kind of write my 7s with a line through it, but that's just a 7. My x value, which goes here, it's telling me my x is 3. So what goes in there is 3. Now we can see a couple options here. You can see these 7s are going to cancel out, but even if you didn't, you're going to have 7 over, this is again is 7 times 3. 7x means 7 times x. So 7 times 3 would be 21. Problem is that's not reduced. 7 will go into both of those numbers. In other words, I'm dividing 7 into both. And that's going to give me 1 over 3 as my answer to that problem there. All right, another way you're going to see this written is, it'll say is, let's see if I can squeeze it in here, is 2 a solution of the equation (2x plus 7 equals 5x). So what they're telling you is they're saying if you substitute 2 in for x, in other words, they're saying if x equals 2, are these two sides going to be equal? Is 2 going to be, because if it's a solution, that means they have to be equal. If when you substitute that 2 in for x, they're not equal, you would say, no, it's not a solution. Well, let's figure it out. Again, everywhere there's an x, what am I going to do? I'm going to write it first with the parentheses. And then I'm going to substitute 2 in where the x is. Because it told me 2 is a solution. 2 is basically telling you where you have your x, you're going to substitute 2 in there. Right? Again, this is 2 times x. So I'm doing 2 times 2 first, based on my order of operations. It's 4 plus 7. I could do 5 times 2 on this other side too. I'm going to get 10. Now what is 4 plus 7? 4 plus 7 is 11. Does 11 equal 10? It's 11 and 10 the same number? No, it is not. So the answer for that is no, it is not a solution. If when you substitute it in, you got the same number, they were both equal to each other, then you would say, yes, it is a solution. Right. All right, the next thing you're going to do is they're going to give you what we call kind of just a number sentence, and they kind of want you to convert this into an algebra, not an equation, but an algebraic sentence. So anytime you see the word a number, and I know on these problems they tell you to use x as your variable, okay, just keep that in mind. But a number, basically, we don't know what number they're talking about, right? So it just says 9 subtracted from a number. So anytime you see that, that's where you're going to use your variable. And in this case, they want you to use x as your variable. And this is a very common mistake that you're going to see on this type of problem. Because when the way you read it, you think the 9 comes first. So you think it's 9 being subtracted by x. Okay, but really what it's saying is 9 subtracted from a number. So if I said 9 subtracted from 10, you're going to start with 10 and subtract 9. Okay, but in this case, we don't know what that number is. So we use the x as the variable. But the way this is written is x minus 9. I know that's going to be a little confusing because the way you read it, you think the 9 comes first. But it's 9 being subtracted from a number. So you had that number first, and you were taking 9 away from it. Let's do a couple more examples. There's also a really good slide that I'll show you in a second from the PowerPoint that helps convert some of these words into different operations. All right, so this is 3 times a number. So again, a number, and it tells you to use x as your variable. So anytime we see a number, we know in this situation we're going to use x. So how do I show 3 times a number? Well, you're going to think you're probably going to want to write 3 times x, okay? Remember, 3 times x is the same as 3x. So you don't normally put a multiplication sign in between them. You just write 3x, okay? And then increased by 1. Increased means we are adding 1. Decreased mean we are subtracting 1. So basically, when you see 3 times a number increased by 1, it's 3x plus 1 would be your answer there. Let me go, let me just show you that PowerPoint slide. Get back, find it. Make sure, share it. $1.4. It's this one kind of right here. Let me see if I can make it bigger for you. All right, so it just kind of helps you, gives you, you know, you have your increased by, decreased by, that means you're adding, subtracting, times, multiply twice. Of is a big one, okay? Of means multiplication. Quotient is the one you'll see a lot for division. And the equal sign, the big one with the equal sign is the word is. Okay, but again, this is a good little slide here that kind of helps you taking these phrases and converting them into equations. All right. The next way you're going to kind of see this, I want to kind of show you this. Kind of goes back to when you're substituting these values, and the problem kind of looks like this, and you see a semicolon too. Basically, all they're telling you, and I think you're going to see the wording, is to a solution to 2x plus 4 equals 5x minus 3. Excuse me. And all they're telling you is, when you see it written like this with this semicolon here, basically they're telling you x equals 2. Okay, and it doesn't really have anything to do with the problem itself. But they want to know, if you substitute 2 in for the x here and the x here, are these two problems going to be the same? Are these two sides, are these two equations, each side going to be equal? So again, I'm going to rewrite the equation. Wherever the x was, I'm going to put parentheses. I'm substituting, what am I using for 2? I'm actually using 2. It's probably the second problem we've used where 2 is the value we're substituting. And again, when I don't see a sign in between the 2 and the x, I always know I'm multiplying. So I'm multiplying right here. 2 times 2 would be 4. 4 plus 4 gives me 8. And then I go 5 times 2 would be 10. And 10 take away 3 would give me 7. So they are not equal. Okay, if they are not equal, then the answer is no, that is not a solution. If the two sides were equal, then I would say, yes, it is a solution. All right, and just kind of the last one. It's a little bit of everything with order of operations again. So let's just go through this step by step. First step, again, is parentheses. We do have parentheses, so we're going to do this inside here first, which would be 3 plus 5. Now this would be one where I would leave in the parentheses. The reason being, if I took it out, I don't want you to think that that's just 88. Okay, so again, I did this right here first, 3 plus 5. That's where I get the 8 from. And again, remember, it's 8 times whatever 3 plus 5 is. All right, but if we are doing order of operations, we just did parentheses. Our next thing we were supposed to do before we multiply is the exponents, and we do have an exponent right here. And that's 4 squared, which is 4 times 4. And 4 times 4 is going to give me 16. So again, I've done my order of operations step by step. After exponents, we did parentheses. We did exponents. We've got to do this multiplication here next. Okay, and so what is 8 times 8 would give me 64. So at this point, what you'll notice is we have addition in both places. So we kind of can, since they're not really left or right, it doesn't really matter. We can do them both at the same time. This would give me 68 over 20. Now again, very important. I do not enter that answer. The reason being, I have an even number over an even number. So at the very least, we know I can keep dividing 2 into this until I don't have even numbers. All right. So if I do 68 divided by 2, that would give me 34. 20 divided by 2 would give me 10. So again, I'll say, well, I'm not done because I got an even over an even. But again, I keep going, dividing 2 into both of those. And this would give me 17 over 5. At that point, I don't have an even over an even, and 5 and both 17 are my primes. So this would be my answer. What that tells me is if I divided this number as it was by 4, it would have took me right to the 17 over 5. So there you go. Those are some examples of what you will see on 1.4. And I will have more videos posted on the other sections coming up soon.